The plan was, because we often talk about artificial intelligence, and honestly speaking, I can't follow everything anymore about deep learning, machine learning, AI, what are the different types of AI. And that's why we were trying to find someone, and we hope that you agree with us that we have found this one in Hederik Laloo, who's going to explain us a bit the world of AI. Welcome, Hederik.
Thank you. Can you hear me?
Okay. Yes, perfectly fine. So I'm going to hand over to you. You can share the slides, and then it's all yours. And also after every session, we can have people for we can have your questions in the chat or through the Slido. Okay, all yours.
Maybe one last question. Can you see my slides, Johan? Because I'm sharing.
Yes,
I don't know if it's visible.
Perfectly fine.
Thank you.
Perfect.
So hello, everyone. As Johan mentioned, my name is Hederik Laloo. I am the CEO and founder of the Product Architects. And I was asked to give you an introduction on AI, or the world of AI. And I'm going to try and do that. So why me, or why am I on stage now? I'm not a programmer. I'm not a Python programmer. I need to specify that, but we are a product design agency. So we have been working with car dealers across Europe in building digital platforms. And what we do is we are an ideation firm. We help transform vague ideas into fast prototyping concepts, which we test with users. And then afterwards, we give that concept to development agencies such as Expert Network, who are highly sufficient in AI and other development as well. So from a fast prototyping perspective, we need to be aware of all the latest technology out there. And we need to see whether the product market fit that you're trying to address is suited for AI or any other application, and what is the best solution there. So from that perspective, I wanted to give you an explanation on AI. Now, you have to know that AI is a container concept. It covers a huge field of mathematical systems, robotics, algorithms, and we could honestly say that it's too vast now. And if I would go through every definition that underpins AI and every subdomain, it would probably take me 2 hours. So I have focused more on deep learning and machine learning, and I'll get to that later on, because they are the most relevant in your field and in your domain. So, but if we go back to the root, the first definition, the one that I think honestly makes the most sense, you have here on your screen John McCarthy, a mathematician, a very famous one. And in 1955, he said, we are at a stage where every aspect of learning or any other feature of intelligence can in principle be so precisely described that we are getting access to an age where a machine at some point can simulate that. So it is also AI, unfortunately, is also the field of really describing very precisely what something does. And we get to that more at a later stage. But so John McCarthy did a good job at defining that. Later on, there were other definitions saying that artificial intelligence is the science of mimicking human intelligence. And we can go on and on and on. This is the first one and the most purest one to a degree. So looking then at the market of AI and the pioneers, the early pioneers that really shaped the market of AI, we cannot ignore Alan Turing, who during the Second World War created the first computer that broke the Enigma device from Germany to translate encrypted messages. And Alan also created a test which is called the Turing test. Probably you've heard of it. It's a test that will try to separate humans and AIs. So if an AI passes the Turing test, that means that the Turing test can no longer see whether it's just a rule-based thing replying to you or whether it's a human. The difference can no longer be distinguished. And that Turing test improved over time, but is still used today. And only a few AIs managed to beat that, especially in the natural language processing field, where there were some breakthroughs where they could fool the Turing test. Then you have Marvin McKinsey, who is the godfather, so to speak, of the neural networks. So neural networks is a part of AI. We'll get back to that later. But in the end, what AI tries to do, or the best results that have been achieved so far, is by trying to mimic what happens in the human brain. And that's all about neural networks. and Marvin McKinsey made some groundbreaking models on that. And you have also Ross Quaylen, who worked on NLP. Very important also, everything that is chatbot driven relies on NLP. And you have Edward Feigenbaum, which is also a very famous mathematician, also one of the godfathers in AI, because AI is all about how do humans learn and how can we translate that into the programming world. It's all about learning and applying those learnings in order to improve. So we had to map at some point how a human learns and translate that. And that is something that Edward did. Then maybe some other pioneers that I think you should know of if you dig a little deeper, if you go into the topic, is that Python is the language of the AI world. Python is a very famous programming language. It's the predominant one in AI. And there are two companies working really hard on creating, let's say, a vocabulary, a library on that, and that is Google and Facebook. So Facebook has TensorFlow, which is fully in Python, and you have PyTorch, which is fully in Google. And those are two, I would say, dialects that help you program much faster, and that allows you as a programmer not to be super efficient in mathematics and still be able to create AI. So these are a bit the pioneers. So if you look at the world around us today, there's a lot of AI influencing us already, and some people are not aware of that. Of course, we have the famous example of Tesla, the self-driving cars. We also have Google Maps or Waze, which is a system that actually in real time retrieves information from every iPhone, smartphone on the road, and that looks at the congestion speed. So it actually calculates, if you would type, I want to drive to Ghent now from Antwerp, it will calculate how much time it would take you, taking into the account the current situation on the road and extrapolating that to the future. So AI is often a mathematical algorithm that is automated to predict something of the future. Most of the time it's that. I know that some mathematicians will not agree with me, but it's always prediction driven. And Google Maps does that very, very well in real time. And there's a very complex algorithm behind that. We also have Siri and Alexa, which are two very famous virtual assistants. We also have the smartwatches that are becoming more and more important and that have saved lives, because a smartwatch can detect whether or not you have heart failures or small heart rhythms that are not really okay. And so people have been warned about the possibility that you could be liable for a heart disease in the coming years. So all that technology makes us superhumans more and more. We have those little computers in our pockets, on our wrists, and they're full of AI-driven application. Of course, chatbots, which has been mentioned before by the other speakers. We have Twitter, we have Facebook, we have Google. Every time you type in on Google something, Google will create a list for you. What very few people know is that if I type in the same word as you on Google, we will both get a different list based on our search patterns in the past. So it becomes highly personalized. So we think that Google is the same for everyone. That's not true. Google is personalizing information. Also, something that is really beautiful is that in the health industry, AI is really helping us to save lives. So AI will analyze an MRI scan where it took in the past six or seven specialists to analyze that for 8 hours, and AI can now do that in 5 minutes time. So the analysis of an MRI goes really fast. And then another example of AI that's already old, it's already 10 years old. We don't know this, but if you go to a dermatologist and you have a mold, a skin mold, we can take a picture, or a picture can be taken of your skin, and they can tell you within 2 minutes, with a 99.9% accuracy, whether that mold could become a cancer sooner or later, or if it's already a cancer. So AI is already all around us and is here to stay. But then again, looking at AI and its history, we see that AI has often had an undertone of fear. We're going to take over the world. We had Terminator in the past. We had Space Odyssey. We also have a very famous man in the car industry, Elon Musk, that is investing heavily into AI, by the way, but predicts, oh, AI is really dangerous. It's more dangerous than nukes. Why is he saying that? But he has been known to manipulate stock prices in the past. So he develops at the same time he scares everyone. So is it a marketing trick or not? Do we need to fear AI? And how powerful is AI today? And what can it do tomorrow? So in order to answer that question, I wanted to zoom in on 3 types of AI. You have artificial narrow intelligence, what we often call weak AI, and that is all the AI you know. 99.9% of the AI you know today or you use is narrow AI. That means it's an AI specifically built to do one specific thing really very well. The disadvantage is it cannot do anything else aside that really specific thing. Then you have artificial general intelligence, which is strong AI. There's only one true application of that, which is the Kato application. Some are it's a highly contested example still. Some don't believe it's a general artificial intelligence, so an AI that can do more than one thing. And then you have the super intelligence or the artificial super intelligence, the ASI, which we're nowhere near yet, meaning an AI that can mimic the human brain fully to its fullest extent, learn everything super fast and beats us in every direction. So that is still a very theoretical form of AI. And if we want to zoom in on a specific field of AI, we are going to look at machine learning, because it's the process, it studies the process of learning and how a human learns. And from machine learning, there are other domains that emerge, domains that you know. So machine learning is going to be my main topic here. But we could also have been focusing in on robotization, arm robots, composing a car in a factory, which is a completely different form of AI, but also a valid one. It's also AI. But today I wanted to focus and zoom in on machine learning. So AI or machine learning is a domain within AI that focuses on algorithms that improve automatically through experience and learning. So I have to explain you how this works. There are 3 different ways an algorithm can learn and improve, and maybe that's interesting to know. Please note that if a machine learns something, it can only learn if you feed it enormous amounts of data. So this is also one of the Achilles parts of machine learning. It needs to be fed a huge amount of data. And there you have 3 different ways of learning. Unsupervised learning is where the data is less categorized. We give it less labels. This is a male of 40 doing this. We could label that and then feed that into an algorithm. That is supervised learning. You already start to feed it some patterns, knowingly that you're feeding it patterns. If you have less categorized data with less patterns that you recognize as a human, and you want to feed more or less the raw data to an algorithm, it becomes unsupervised. It's a bit short when I'm explaining. I could go deeper into that, but at least that divides supervised and unsupervised learning. And then you have the last form, which is not often talked about, but really often used. It's the reinforced learning. You have an algorithm. It is built to do a certain thing, and every time it does it well, you reward it. And every time it does it wrong, you tell it this is a wrong result. So reinforced learning is also a method of learning. So you've probably heard this, but deep learning is the domain that's taking over. Every new invention out there is all about deep learning. And deep learning is the domain within AI that focuses on algorithms that really improve over time and that learn through experience. And what that means, it's still a form of narrow AI, but let's say it's a very long and large decision trees and with conditional clauses. If this happens, then do that. If this happens, then do that. If then clauses. And what an algorithm does that self-learns is it tries to change the weights within that tech tree. That's all it does. So it's a really elaborate tech tree, and with the deep learning and neural networks, it's just a much deeper tech tree or decision tree. And all it does is changing the weights of the decisions. So what are famous examples of deep learning? Your facial recognition software on your smartphone is a true example of deep learning. Google Flu was one, an autonomous vehicle. It's really good at driving a car, but don't put a Tesla on top of a plane. The plane will not be able to use the software in the Tesla if you don't do something with the software. It will not work. It's also very good in cyber defense, weather forecasting. Google Translate is also a deep learning algorithm, and virtual assistants. So there are some true limitations with narrow AI. And do keep in mind, I told you that it's still 99% of all the AIs that we know, is that it is only as smart as the information we feed it. And an example, a famous example of how AI can go wrong, and maybe you're not aware of this, iPhone invented facial recognition. And with the first release of facial recognition, Apple discovered that Black people with black skin, they had a huge problem with identifying their faces because they forgot to test data with colored people. So they only tested it on white males and white women and Asian type people. But they forgot to test it with Afro-American people. So the AI, as clever as it was, wow, it does facial recognition. It couldn't recognize people of color, and it still has a huge problem doing that today. So, and why is that AI bad? Not at all. But it's only as clever as we feed it. If we forget to feed it quintessential information on the prediction level, is this the face that you saw yesterday? And you don't show that algorithm the right information, it will not be able to handle it. So it's very important to know that the AI that we use is bound to some limitations. A few other examples. And you can look the famous TED Talk, you can see it online. So the fear of artificial intelligence, the fact that we could wake up tomorrow with a Terminator next to us, still far away from us, as many experts say, because the algorithm has been fed. There was this algorithm at the Harvard University that was studying multiple ice cream names, because there was, for instance, a famous ice cream, which is Coconut Beach, which is in the US, a combination of blue curacao with cocoa flavor in an ice cream, and it had a beautiful name. So it fed all of names and combinations of foods, and then the algorithm had to make their own inventive ice creams, and they came up with strawberry cream disease, peanut butter slime, pumpkin trash bread, because everyone in the test forgot to tell the algorithm that the names that we currently use for our ice creams are associated with positive things. So coconut and beach, that's positive. Now, disease, if you look at the ice cream there, it has spots. People who are diseased often have spots, and that's why the algorithm thought, I think that's a great name for an ice cream. Where in practice, we as humans will say, oh, no, this is a really bad name because you'd actually fear eating the ice cream. So you see, there are still limitations. Then you have also the famous Uber cars of Volvo that drove around. I think it was in San Francisco, and one of the cars drove through a red light and had a huge accident. Why? Because some of the drivers that were using the car in the beginning to let it learn how to drive sometimes decided to skip the red light because there was nobody on the... It was at night, there was nobody on the road, and they took the risk of crossing the red light. But the algorithm learned, well, it's okay to cross the red line if I deem it necessary to get quicker to my next destination. So was it the flaw of the algorithm? No, it was the flaw of us humans feeding the algorithm really bad information. So maybe another example that I wanted to highlight, probably you have heard the AlphaGo experiment. Go is one of the most famous board games in the world, or most difficult one. It's more difficult than chess. And everybody deemed it impossible for an AI to beat it because it had an infinite number of possibilities, whereas with chess, there is a finite number of possibilities. So the AlphaGo team found a possibility to work around that, and now no one can beat the AlphaGo algorithm anymore. But that AlphaGo algorithm can only work on AlphaGo. If you now feed it a very famous game that I play with my kids, and many of you will probably know, the Settlers of Catan, probably coding the rules of Settlers of Catan will take a couple of ICT people, I don't know, 2 or 3 hours, and it's coded. Well, AlphaGo cannot play Catan after 2 or 3 hours. But if you explain to a kid the rules of the Settlers of Catan, immediately they can start a game. So again, to show you the complexity of AI, you need vast amounts of data. You need the algorithm also to play the game, or to feed him with simulations of played games in the past before he can play. Just to show you that, yes, AI is powerful, very powerful, can process data much quicker and much more accurate than us humans, but it's still very narrow in its application. Then you have today also something that I think is interesting in deep learning is we are now seeing the application of deep fake, and I heavily suggest you do that. Type in deep fake on YouTube and type in, I don't know, Putin or Obama, and you will see that there's an actor speaking in real time in front of a camera, and his face is being changed into the face of Obama. And you actually think the first minute that it's Obama speaking, or Putin, or the Queen, or Tom Cruise, and it's not. And predictions are being made that in politics worldwide, deepfake is already being used from time to time to manipulate people. So deepfake is spectacular. It's lovely. You can do beautiful things with it, bad things as well. And what it did is actually study the face of Obama, every performance he did live, the way he talked, the way he moved his lips. And the algorithm tried to deduct, it was unsupervised learning, it tried to deduct patterns out of it and then apply those patterns to an actual actor speaking now and putting the face of Obama on it. And you cannot tell that it's not Obama. It's impossible to see. So deepfake, very interesting technology based on deep learning. And now some other examples that I think are beautiful. So I don't know, people that are into classical music, you have Schubert. Schubert has an 8th symphony, which was never finished. And Huawei studied all the patterns of all the music scores that Schubert has ever written. And then the algorithm completed the uncompleted symphony of Schubert. And it's beautiful. It's beautiful. It's not crappy. It's not terribly fake. And a lot of musicians, top musicians in the classical industry, they were amazed by the scores. It was beautiful. It was a wind simulation of violins and clarinets playing, which is typical for Schubert. And it was all perfectly done with a new score never seen before. And nobody could say, this is not Schubert. Everyone said, but this feels and is actually Schubert, which is great. So algorithms are amazing at predicting patterns or other patterns, or predicting, if we have this car next summer and it will be this temperature, what are the chances for us to sell this car? So predictions based on future trends, if you feed it enough past information, it can do incredible things. The same for cancer. For the cancer industry, a lot of pattern recognition is being used there as well with the strong new NVIDIA computer. These are all examples of deep learning. So I don't want to take too much of your time, but so does AI pose a threat to the world? Is it going to be the next Skynet? Is my iPhone going to be tomorrow morning waking up, being sentient and taking over my life? No, we're not there yet. We're getting closer. We already see some multi-purposed AI popping up, but it's 0.1%, and it's still very limited. But AI is doing wonderful things in Medicare. It's saving lives. It's convincing people. It's creating self-driving cars, which at some point will be the future. AI has the power to mislead and misform and to be used as a power tool. But on the other hand, we're still caught in weak AI. I really don't see how we will wake up next year or the year after with a predominant strong AI multi-purpose. That's not going to happen. Most experts think it's still 20 years away before strong AI emerges. So which AI trends are we seeing in the car industry and are becoming more dominant? Of course, you all know this probably better than me, but car factories are less and less depending on humans. So it's fully automated. Tesla is already doing this. Self-driving cars at some point are going to be the standard, but also hyper-personal cars. So it will be able for a client to enter at a dealer and say, I want this car with that. And the level of personalization and the automated supply chain assisted with AI will make sure that you as a customer can go much deeper in your personalization of the car without any issues. So that's also a prediction that the Times did. It's going to happen. It's also beautiful to know is the car on the right side of the screen in the little balloon is a fully AI designed car. This car, no human was ever used when designing this sport car. And there are more and more examples. If you type in on Google AI designed cars, you will see that there are a lot of AI designed cars, a lot of AI designed music also on the market. So AI is becoming creative in Gen 1 field, the field that the AI was created for. It's very good for price indication, stock rotation prediction. AI will also be used and is already being used to say, I am this person, what is the car that fits my need best? So that recommendation layer, everyone is predicting that is going to go through the roof and be much more efficient in the future. We see the supply chain being automated on every field. And there's also a prediction of the times that car manufacturers and ICT companies are going to merge. It's no longer going to be ICT companies aiding car manufacturers. They are going to merge together. And we see that already in the market. So that was a little bit my short and I would say, simple introduction to AI. I hope it was not too complex. I hope it was informative. And I'm at the end of my presentation, to be honest. I hope I'm still within the time frame.
Yes, Hederik, perfectly fine. Thanks a lot for this. Well, yeah, it could have been that it was still not too deep, but of course, for a lot of people amongst the audience, I think we're all in used cars, remarketing, automotive, but of course, we're not experts in AI. So I think this is a great intro. If anyone has a question, please feel free to add it in the chat. Now, Hederik, maybe just to start off with a question here. Of course, you're involved in a lot of different projects, online stuff in automotive, but also outside of automotive. Can you elaborate a bit on? I can imagine that applying AI within companies or within processes or things is a challenge for companies. They don't understand. It's hard to understand. Senior management won't ever have the time to understand it. So I can imagine that implementation or getting it approved on an agenda could be a challenge. How do you see this? Or are there advices for people to say, look, really do this or start with that, or in the approach?
I think in the approach, I think at the end of the day, but that's my conviction. I have worked also at many multinationals and corporates. I think in the end, we should see AI not as a threat, but as something that will help us improve, do our everyday jobs. For instance, now lawyers at JP Morgan, they now have access to an AI which was created by JP Morgan and a lot of Python developers. And when an AI needs to draft, when a lawyer needs to draft a specific contract for an investment or whatever, he will go to the AI, in the in-house AI, and that in-house AI will ask some questions, will read all of the applicable legislation, and already create a draft contract, which is 99% good. But you still need the lawyer inside to sign off, to read it through, to amend it a little bit. But that lawyer can now draft that contract 6 times faster than before. The algorithm is that powerful that it can create 25,000 contracts a day. Of course, for that big bank, there are many contracts being drafted every day, so it's still good. But nobody hesitated. Not one lawyer, not one legal expert within the company had an issue with having that AI implemented, because there was still a human involved. There was still human curation. Is this good? It was still being read through, and it still is being done today. If you now go to a car dealer and you say, let's use software to predict how much stock we have to buy and how quickly it rotates, and let's find the optimum there, and AI would do that perfectly, I don't see why a dealer would refuse that. The problem I see is mostly on the part that there is a huge war on talent going around everywhere in Europe, and getting hold of people who can program in Python and who are sufficient, that is going to be the challenge. But I'm hoping that more and more people will see the benefit of having a more comfortable job, a more higher qualitative output, and see yourself still as playing a quintessential role in the value chain. Only part of the preparation and the predictions are going to be much better if an AI supports you. So I would always present it as an improvement in quality. And all the AIs that I have worked on, I've also worked at InvestSuite, they have improved people's lives. They have improved efficiency. They haven't destroyed jobs as many people predicted. Oh, the AI is going to destroy jobs. Of course, we could discuss that Tesla has factories that no longer uses people, but still Tesla employs a lot of people on other domains in marketing and so on and so on. So I'm hoping that you in the audience see AI as an enabler instead of a threat. That was a little bit my hidden purpose of the presentation, but maybe I failed if you asked me that question.
No. I don't think so, because a lot of the companies in remarketing automotive, they are working with AI, certainly with data, chat, inspections, and everything. But I think it just, of course, if someone is responsible for the marketing, they won't be the experts, and they need to explain to other people who aren't experts what it could do. So I think it could fail a bit in people's perception a bit. I think that could be a challenge as well. But of course, that's why that's why you as a company as well help companies in analyzing this as well. I think.
I think you're right. That will always be viewed as a threat if you somehow fail to properly explain it. But I think if you focus on the problem you are trying to solve for whatever user, your customer, and you start from the problem and try to fit the best solution, find the best solution to solve the problem, then AI could be one of the possibilities, but doesn't have to be the possibilities. Some companies came to us, we want a digital platform to do this X, Y, Z, because most of the time we do this under NDA. Then we can sometimes quickly solve that with a purely rule-based setup, which is not really AI, which is a very, very weak form of AI. So I always think, let's focus on the problem we want to solve and then choose the best possible solution. And if that solution is the most adequate, then you are capable of convincing senior management at whatever corporate or smaller company. But maybe I'm being a bit naive and optimistic, and you still have a point, Johan. So thank you for...
No. I think, look, it's I think it's interesting to see it as a challenge as well. But certainly, I think it can bring efficiency, both from costs, maybe on an HR perspective, or it frees up time to look at more quality as well, which at the end I think is key. Thanks a lot for the intro. I think it was a real good one to start with. And after this, we're going to move over to a very specific one that I think people experience already every day. So, Hederik, thanks a lot. And if people would like to contact you afterwards, you will find all the PowerPoints and the videos on the YouTube channel of Fleet Europe. And there you can find all the information. Thanks a lot. Okay, ladies and gentlemen, I hope that I will stay on for a while, the next year maybe, but otherwise they put someone else here with the deep fake, and then you still might see my face. But for now, I think I will start.